Welcome back to our imaginary spaceship, where we explore the universe's secrets together. On this new adventure, we're heading towards our life-giving sun, the very star that protects our planet from the cold, dark infinity of space, and one day might be the reason for its end. Now, take your seat, lean back, and enjoy the journey. To fully grasp our sun and its importance, we're pushing the boundaries of physics a bit. We're setting our spaceship to travel back about 5 billion years in time. We've arrived at a dark, misty place. There are no planets or stars, just a lifeless graveyard. What you see is a nebula made up of various elements. Long before our solar system existed, a star ended its life here. According to theories, this ancient star didn't explode, but slowly lost its outer layers, fading away. However, we can't be entirely sure yet. But here's a fact: every person you've ever known, everything around you, all came from the elemental dust of this ancient star. Religions debate over humanity's origins, but in reality, both humanity and everything on this planet share a common ancestress star that reached the end of its life billions of years ago. You can see part of the nebula where gas and dust are coming together, forming a larger cluster. As its mass and volume grow, it pulls in even more gas and dust. This process can take hundreds of thousands, maybe even millions of years. Right there, in that massive swirling vortex, something's happening at the very heart of the dust and gas cluster, heating up from friction and pressure. Billions of tons of matter interact under such immense pressure and heat that the vortex's core reaches 14 million degrees. This triggers a fusion reaction, and there it is, the first heartbeat of our beautiful system's king. A cosmic candle burning in the pitch black, offering light and security. A torch that has guided us through the ages, shining its light for the first time. With the birth of our sun, its light reveals a fascinating scene. Do you see the other swirling dust and gas vortices? Each one is the early form of a future planet in our solar system. First, Jupiter and the other gas giants will be born, and from what's left, the solid materials will form the rocky planets Mercury, Venus, Mars, and our home, Earth. Isn't it strange? The universe beautifully shows us that every end is a new beginning. The star that died here billions of years ago might have once hosted a civilization much like ours. Its destruction led to the birth of our solar system and, eventually, our civilization. When you consider the universe's vastness and its 15 billion year history, it's hard to grasp who's come and gone. In its early days, our sun emitted about 40% less light and heat than it does now. Every 100 million years, this increased by 1%. Based on this, scientists believe that back then, Mercury and Venus, located closer to the sun, were very different places compared to today. It's even believed that Venus once had liquid water and possibly life. Like a moth drawn to a flame, we bring our spaceship closer to the sun. This majestic view has mesmerized countless civilizations for thousands of years. According to many ancient beliefs, you're now looking at the face of a god. Early humans, observing nature, saw this celestial body as sacred, as it brought life and vanished in winter, taking life with it. But today, thanks to science and technology, we know we're not looking at the face of a god, but at a massive fusion reactor. With a core temperature of 15.6 million degrees, 600 million tons of hydrogen turn into helium every second. The energy released is so immense that the sun produces more energy in just 3 days than all the natural gas, oil, wood, and coal on Earth combined could ever produce. If our solar panel technology could convert 90% of the sun's rays hitting Earth into energy, a solar farm the size of Ankara could meet the world's entire energy needs. From a distance, our sun, which lights up our days and warms us, seems calm. But it's actually a chaotic, dynamic structure. As you can see now, magnetic ripples and plasma eruptions occur constantly. This happens because the sun's core rotates every 7 days, while its outer layers take 24 days. Remember, what you're looking at isn't a solid object, but a mass of plasma. This means it sometimes experiences regional speed differences. As a result, dangerous coronal mass ejections, CMEs, occur. You might never hear about these events in your lifetime, and hopefully, you won't have to, because if one day, an eruption like the one you're seeing now happens to be directed toward Earth, you might wake up to a world thrown back to the Stone Age. These highly charged solar bursts have the potential to completely fry the planet's electronic infrastructure, depending on their intensity. So what if an even bigger mega-eruption occurs? Recent studies suggest a similar event happened around 10,000 BC. Back then, it caused a sudden melting of glaciers, which covered about 30% of our planet. This melting, combined with atmospheric destruction, may have triggered the Great Flood, known as Noah's Flood, leading to the collapse of ancient civilizations and massive loss of life. Just as the Sumerians wrote in great detail thousands of years ago, never forget, the sun, the very reason life exists on Earth, also holds the power to end it in an instant. And unfortunately, one day, it will use that power. As I mentioned before, our sun is a gigantic fusion reactor. Like everything else in the universe, it follows the laws of physics. This means, like any energy-producing entity, the sun's fuel isn't infinite. One day, it will run out, and when that happens, our solar system will face a massive transformation. To understand why and how a star dies, you first need to understand how it works. Stars are structures with immense mass. By universal star standards, our sun is considered medium-sized, yet it accounts for 99.8% of the entire solar system's mass. All the planets, asteroids, and moons make up just 0.2%. This shows how incredibly dense and massive the sun really is. Due to this immense mass, its gravity exerts unimaginable pressure on its core. However, opposing this force is the immense energy produced by the core, pushing the sun outward. It's a battle of forces that has lasted billions of years. Currently, our sun generates power by converting vast amounts of hydrogen into helium, but hydrogen isn't endless. In fact, the sun has already reached half its lifespan. In about 4 billion years, it will run out of hydrogen and start burning helium. This will disrupt the delicate balance between gravity's pull on the core and the core's outward push. Helium is a heavier element, so for the sun to start burning it, the core needs to heat up even more. As hydrogen runs out, the outward pressure from the core weakens and gravity compresses it further. The core will shrink, but its density and temperature will rise, gaining enough power to burn helium and turn it into carbon. As a result, the sun's outer layers will begin to expand, slowly engulfing Mercury and Venus and growing almost to Earth's orbit. By then, all the water on Earth will have evaporated and the atmosphere will be gone. Our planet will appear as a lifeless, gray rock, a stark contrast to the vibrant world it once was. As Mars becomes a much warmer planet, the underground ice will melt, rebuilding its atmosphere and possibly bringing back the life that once might have existed. Meanwhile, the frozen ice seas of Jupiter's Europa and Saturn's Enceladus will begin to thaw, turning these icy moons into water worlds where new life could be sparked. For carbon to turn into energy, a star's core needs to reach 100 million degrees, and our sun isn't even close. So what happens next? Remember gravity, which has been trying to collapse the sun for billions of years. As the sun runs out of helium, gravity finally gets its chance. Over the next few thousand years, it will crush the weakened core. Gravity attacks with such force and speed that the core gets crushed even further. We move our spaceship to a safer distance because what's about to happen is incredibly dangerous. And here it is. In just a few minutes, the energy released surpasses everything the sun has emitted in its 10 billion year lifespan. This is called a helium flash. The core now reaches 100 million degrees, enough for carbon fusion. And with this new power, the sun expands even more. And in this process, it tears apart what was once our home, Earth. The sun is now a red giant, but this growth comes at a cost. Its carbon reserves will last only a few million years, and due to its size, no matter how much gravity tries, the core will never reach the 500 million degrees needed to burn elements beyond carbon. And now we're nearing the end. The sun burns its last bit of carbon, but gravity's pull can't make the core hot enough. Since our sun is a medium-sized star, it won't become a supernova or black hole. Instead, a long retirement awaits. The crushed core has shrunk to about the size of the Earth it once consumed, and with its fuel gone, the sun's massive outer layers begin drifting away. All that remains of this once giant star is a small but incredibly dense white dwarf. Just a teaspoon of it would weigh tons. The core that once burned at 100 million degrees now sits at only 100,000 degrees and will slowly cool over the next tens of billions of years, eventually becoming a black dwarf. Because they cool so slowly, we've never found a black dwarf. The universe is only 15 billion years old, but it takes 20 to 30 billion years for a white dwarf to fully cool down. It's time for us to leave and let our sun enjoy its well-deserved retirement. The once vibrant solar system that hosted human civilization is now finished. With the sun's gravity greatly weakened, the gas giant planets will break free from their orbits and drift into the void. Each will face a very different destiny.